So now you, via the interpreter, are going to write the first part of our parser. Our parser is just going to build up this big variable chart, and we've already seen how to seed it with an initial value for chart state 0, and also how to see if a string is accepted by grammars in the language of the grammar by checking chart t if there are t tokens to kind of see if it has the final state. So let's say we're deep in the middle of this. We're currently looking at chart sub I, and we see x goes to ab.cd from j. We're going to write the following code in our parser. We're going to call a special function called closure and pass it the grammar, just as we described before. I, which is going to be a number, that's the chart state we're looking at. X, that's going to be a single non-terminal. AB, that's going to be this list here, could be empty, could have many things. And CD, that's this list here, could be empty, could have many things. And this closure function is going to return all the new parsing states that we want to add to chart position I. So it's going to return a list of next states. For each one of those, we're going to add it to the chart. We've already written add to chart together. And we're going to figure out if there were any changes over all of the things you returned. For example, let's say you returned 3 things, but 2 of them were already in the chart. Since at least one of those was a change, then we want any changes to be true. So this blue code here, this is locked in stone. I'm definitely going to use this. But you can write any definition for closure that you like, as long as it correctly implements how the closure is supposed to work. Go forth. This is relatively tricky, and here's my hint. If you're stuck, do a list comprehension over the grammar rules. Remember that you're trying to return states, and every state is pretty much like a grammar rule, but with the addition of that red dot somewhere in the middle.